Good morning, ladies and gentlemen of Precalculus. Good to have you here today. Yesterday in class we started on this exercise set and we were rudely interrupted by a power outage. And so we're just going to pick up where we left off yesterday. And basically these exercises 1 through 4 are about just using your calculator to graph parametric equations. And to graph parametric equations, if you look at them, you have these x equals 4 cosine cubed t, and so you have different variables, don't you? And so we're going to get used to that. So what I'm going to do is graph this first one here, and to go and graph parametric equations, what you do is a lot of these things are trigonometric ratios. So for those, you want to stay in radians if possible. And so you go to mode, and in mode you go down here, in my case to this fifth line, and go over here to parametric and highlight it. And then we quit. And then if we go to y equals our function editor, we see something a whole lot different from what we're used to, right? So what we have is, the first one we have is, oops, wrong one here. Here we go. 4 cosine cubed t. And we're going to talk about what that is. We go over here and put 4 cosine, and what we're going to do is put t here. And I think this is about when we got knocked out yesterday, wasn't it? Right at this point. And then we go to the third power. And so in the notation, when they put this third here, what that means is the whole thing cubed. That's what that means. And then the other one, if I'm not mistaken, was 2 sine. It was 2t, wasn't it? Is that right? 2 sine, oh, sine cubed t. So I don't have the 2t here. So I remember it wrong. So it just has t, and we're cubing that, aren't we?
Yeah.
So cubing that, and so we cube that, and if we're in a standard window,
It has the cube of 4 in the t. It's 2 sine cube.
okay, but yeah, what it is, let me show you what that is, because that's actually a good question. What this has to do with specifics of a notation, because when you say, look, do you remember like the Pythagorean identity? Sine squared theta plus cosine squared theta equals 1. What that really means, is it means sine theta squared plus cosine theta squared. That's what that means. So when you see the notation here in this place, that means it's the whole, this thing squared. It's 4 times all this cubed, cosine t cubed. And so that's where that comes from. So it's a matter of notation. So you graph, and I'm going to get to standard window, zoom 6, and that's what we have. And so can you see which graph that matches? So basically you would say, and to work this out, you would say this one here is graph B, right? But Robert, did I answer your question?
Yeah, I did.
Okay, good. And then what you're going to do is enter all these other ones and put them in place and enter. You shouldn't have any trouble entering these things. This one here on 3, you're going to have to square that whole thing again. And here for this one here, problem 2, you're going to put this 2t in parentheses. So it's just really mostly kind of a calculator entry exercise, isn't it? And getting familiar with graphing parametric equations. Do you need me to enter any of these other ones here?
very last one.
The very last one? Okay, sine t minus t cosine t. So I go here, I'm going to clear, so sine t minus t cosine t minus t cosine t. And down here I'm going to clear that and put in cosine t plus t sine t, cosine t plus t sine t. So we graph that, we get this looking thing here, which is the, what do they call that? There's a certain kind of spiral they call it. It's used in art. Any artists remember what that is? It's right over.
The golden ratio.
Yeah, it has a golden ratio in it. It's called an Archimedes spiral or something like that. But it's that thing right there. But in art, Miss Kelso knows. So anyway, that's going to be this one right here, C, right? So this is going to be graph C. So is everybody able to enter those pretty well? Get those? Okay. Okay. Good. Let's go on to this next one, which is 5. In exercise 5 through 6, complete the table for parametric equations and plot the corresponding points. So what we're going to do is we're going to do by hand something that your calculator could actually do. And so you have these two equations. You have x equals t plus 2. And so right here, if we take x equals negative 2 plus 2, what's negative 2 plus 2?
0.
0. So that's 0. If we put in negative 1, negative 1 plus 2 is 1. And then 0 plus, that's 0 here, plus 2, that's going to be 2. And so you have a pattern, right? 3 and 4. So these are our x coordinates. And now for this one right over here, to plug in our y coordinates, we have y of negative 2, I'm going to write it over here because there's a little more arithmetic here, is 1 plus 3 over negative 2. So that's going to be 1 minus 1.5, is that right? Which is going to be equal to negative 1/2. Is that right? Yeah, that's going to be it. So this is going to be negative 1/2 right here. And if we plug in 1, or negative 1, y of negative 1 is equal to 1 plus 3 over negative 1. So that's going to be 1 minus 3 equals negative 2. And if we plug in 2, what are we going to get? If we plug in 0, what are we going to get? We're going to get error, right? So this will be undefined. So this is what Elizabeth was talking about in earlier today, right? And so now we have, if we plug in 1, we get 1 plus 3 over 1. Well, that's going to be 4, right? And if we plug in 2, we get 1 plus 3 over 2. That's going to be 2.5 or 2.5, right?
All right, so I'll be in here 6th period.
6th, Yeah,
Okay, I'll
great.
let you get started and then I'll come on in.
Yeah, great,
And
thanks.
I have rows, so you'll go ahead and take 6th period row.
Yeah,
I'll just do 7th
fantastic,
period row.
fantastic,
All right,
thank you. Yeah, she's going to come in later during 6th period. So now we have all these points that we can plot. And so this is a XY coordinate pair. So we have x equals 0, y equals negative 1/2, x equals 1, y equals -2, x equals 0, x equals, 2, y is undefined, and what we're going to have is what happens when we have undefined. Well, we have, in this case, a vertical asymptote, so it's going to be x is equal to 2. That's our vertical asymptote. And then we have, the next one we have is 3, 4. So to the right 3, up 4. And then we have finally 4, 2.5. So we go 4 and 2.5. And so what we have here is this, or something like this. If we put these together, this is what we would get. So that's what it would be. So you end up with like a rational equation. And then you could actually try this in the calculator, and I'm sure you'd see a very similar thing, wouldn't you? Okay, what I want you to do is go to 6, and what happens here, you should know, you could look at the unit circle and figure what these are, x and y. So if you get out your unit circle, or I hope you can know a lot of these things without getting out your unit circle, that if x is cosine of t, cosine of 0 is going to be 1. We're putting in a calculator. One thing I've seen people do sometimes is change these radian measures into degrees to make it easier, but when you figure all these out, your table should look something like this. Does that look like what you have? A bunch of ones and zeros and -1 and all that. Okay. And so now what you have is something you can plot the points here. So you have your x coordinate, you have 1, 0 right here. You have, and look at the order we draw these things in. Then we have the next one is 0, 1 right here. So we went from here up to here, and the next one is -1, 0, and then we have 0, -1, and then finally we're back to 1, 0 again. So just kind of confirming what's going on in your calculator, if we go to, we can go to cosine t, sine t, sine t, and when you graph this, you'll get something that looks like that. If you go to zoom square, you'll square it up. So you get what? A little circle. What circle do we call this? What circle do we call this? Starts with a U. We sing a song about it.
Unit.
The unit circle trigonometry. Yeah, and the graph is kind of off a little bit, the way the grids are. It looks like that's over to the right some.
Don't even have grid lines.
But let me show you here what happens. is one thing you got to take account of in parametric equations is drawing arrows in the direction of increasing time. I didn't show you that on problem 5. But as time increases, that's what happens. So you have direction related to time with parametric equations, because these things happen at different time. T equals 0, t equals pi over 2, t equals pi, and so on. Okay, the next 4 we have here is we're going to be graphing these parametric equations in our calculator, and I'm going to show you how to do that. So, and then you'll get the hang of it, and then it'll be fine. So the first one we'll go to is right here. Go to y equals. I'm going to clear these guys out. So for this one, what I have is 3 minus t squared so 3 minus t squared, right? And the next one is going to be 2t. Is that right? So we put in 2t, and when we graph, this is what the graph looks like. Now, one thing that we have to do is we are given a time limitation from 0 to 10, as in 0 seconds to 10 seconds. So what we have to do is go to the window, and this is where we adjust it. We go from 0 to 10. What we're doing is we're going from t equals 0 to t equals 10. So I changed this to 10. This third line here is t step, what the thing will go at every time you click. So we graph, and this is what that'll look like. And then what you have is, I'm going to see if trace works here. Can we trace? X. You see trace, yeah. Trace right here. We're starting here at t equals 0. And it gives you the x and y coordinate. And then so you go to the right, you see t getting bigger. So t is increasing. And so this means that the direction of the time is in this direction right here. And let's see, do we go all the way to 10? Yeah, t equals 10. It's sort of off the chart, isn't it? But what we're given a graph right here, as far as the graph comes right here and then goes over here. So the thing is going to go something like this. And it's going to be in direction of time. So you draw the arrow. And what you're going to get for 8, 9, and 10 is a similar, the same equation, but you're going to be given different time intervals for that. Do you see what's going on? You have a question about this? I see studious workers at work here. Do you need me to do any of these others up here? You're okay?
I said number 9.
Oh, number 9, okay. Yeah, number 9, what I'm going to do is get to number 9. Okay, number 9, it's the same equation, but you have a different interval. So we have t from -3 to 3. And so I'm going to go to the window, and now I'm going to put t minimum of -3 and t maximum of 3. And so we get this piece like this, right? And then if we trace, we start here at t equals -3, and then as we increase time, we go in this direction. Now, does a graph like this look odd in your calculator? It should, right? Jana's shaking her head, the birthday girl. Why is it odd, or why is this different? You remember when we did the vertical line test? Remember, you can't have a function if it fails the vertical line test. Does this thing pass the vertical line test?
Yeah, no.
No, it doesn't. But we have to remember that this is a function of time. And so as time happens, if we had an xy coordinate plane, yeah, it fails the vertical line test. But as a parametric equation, it does not, because time is the independent variable here, and not x is the way it amounts to. So in the sketch, we have time in the same direction, but instead we're going to here, here, and here. So the thing's going to look something like this. And then the direction of time is like this. As time increases, that's what it looks like. So just some exercises there. Now, we're going to start on this exercise set today, this other one. I'm not sure exactly how far we're going to get on this. We will at least start on it. Birthday girl. Go ahead, finish with this guy. Now we're to a new set, starting with problem 11 and 11 through 18. It says eliminate the parameter and identify the graph of the parametric curve. And so this exercise set really introduces a little bit of vocabulary, doesn't it? So let's talk about parameter. What does parameter mean? Parameter equals what? Okay, parameter is equal to the variable t. Okay, that's what the parameter is. When you say eliminate the parameter, we're meaning eliminating t. And what we're going to do is we're going to take this parametric equation here, and sometimes you hear it say parametric equation, sometimes you hear people say parametric equations, right? So it's like you could consider either way as a correct one. You could say this would be a set of parametric equations, so you hear different things. We're going to convert these to when we eliminate parameter, so I'm going to say eliminate parameter, and I'll just say eliminate t. And what we're going to have then is called a rectangular equation. So we're going from a parametric equation to a rectangular equation by eliminating t. So what we're going to try to do to get a rectangular equation, we're going to end up with a y equals equation. Is the way it's going to be. So what I'm going to do is we're going to start with this one, x equals 1 plus t, and we're going to solve this equation for t. How do we solve this equation for t? Subtract 1, right? So if we subtract 1, we have, that cancels out, so we have t equals x minus 1. And what can we do with that x minus 1? We can take that x minus 1 and place it right here. So when we do that, I'm drawing these arrows, I hope that's not confusing too much. We end up with y. We end up with y equals x minus 1. So this y equals x minus 1, that is our rectangular version of this parametric equation with t eliminated. And right, by rectangular means just x and y coordinates. And we can graph this. It says identify the graph. So we can go ahead and sketch a graph pretty quickly. What does the graph of this look like? Well, this is what? This is a what kind of shape is this when we graph this? A line, thank you. A line with a y-intercept of -1, so there it is, and a slope of 1/1, right? Thank you. People are kind of muffled behind masks. And so what we have is that's what this is going to look like. And the last thing we can look at is the time. In what order of time is this going to be? Well, if we plug in 0 for t, we get x equals what? If we plug in 0 for t right here, x is going to be equal to what? 1. So that would be right here. If we plug in 1 for t, what is x going to be equal to? 2. And so that means we're going in this direction, right? So this is the direction we go in with time. So you eliminate the rectangular, you eliminate parameter, but now you have direction on the two-dimensional graph, don't you? With time. So that's number 11. I want you to go ahead and work out 12. Let's see if I can look for some helpers on this one. My spinning wheel here. Okay. Yes. We are going to have Riley on this one. Riley? I pulled up your name on this guy. What have you done on this so far?
All of it but the graphing.
All of it but the graphing. Okay, let's just tell what you got, then we'll graph. Thank you. Good work. So what do we do when we
So I rewrote the x equals 2 minus 3t.
So x equals 2 minus 3t.
And then subtract the 2 from both sides.
Subtract 2 from both sides, okay.
That leaves you with x minus 2 equals negative 3t.
Okay, so that's what you have.
And
Okay.
then divide negative 3 from both sides.
Okay. So you got this,
2 equals x minus 2 over negative 3.
so this right here.
Mhm.
Okay, and then, so,
And then set it up with your y, or, yeah.
so you just did
Plug
this,
it into the equation y.
so you just
equals-
plugged it in for here.
Yes. So it's going to be y equals 5 plus x minus 2 over negative 3.
Okay.
And then I graphed it in the calculator.
Yeah, let's just, I want to do one more little thing for this first here. I want to clean this up into like slope-intercept form a little bit. Can we do that? So we have is like negative, that's going to be 5 minus 1/3 x. And then we have plus 2/3. So what we're going to get is, we're going to get negative 1/3 x plus, now I'm going to write this as a mixed number. I hope that won't offend your sensibilities. That's going to be a mixed number of 5 2/3. Does that look right? And when you graph this in your calculator, Riley, did you get something to look like that? What I'll do is I'll just go ahead and sketch it, and we'll see if it looks anything like what you have on your calculator. I hope it does. So our y-intercept's going to be up here at 5 2/3, right? Did you get a y-intercept about there?
Yes.
And then you got a slope of negative 1/3. So something like this. Does that look right? And then I guess the last thing we need to look at is direction of time, right? Because if we plug in t equals, here we have t equals all this. If we plug in 0, we get 2/3. If we plug in 1, we get 1/3, 2/3, 1/3. So your x is, so you're going in this direction, right? I think that's right, isn't it? Okay. And then you can check in the calculator to be sure about it. You can put x equals 2 minus 3t. So 2 minus 3t. And here you had, what was the other one? It was 5 plus t, right? And I haven't changed the time setting at all, but that's kind of what it looks like, right? And if you eliminate the time restrictions, the thing just keeps on going forever. And then to trace, okay, if we go to trace, yeah, that's the direction of time. So looks like a good problem. All right, that is some good work there. Let's go ahead and do number 13. Yeah, go ahead. Number 13. Now this time they're giving us a time restriction on this one. Okay, Karina, I think you're gonna get called on this one just because of the names I'm eliminating here, yeah. Okay. That's right. All right, Karina, you have it all figured out? You're checking on the calculator now? So, what was the first thing you did here? You solve for t?
Yeah.
So, you get 2t equals x minus 3.
Or plus 3.
Well, plus 3, thank you. Thanks for-
Divided by 3.
So t equals 1/2 x plus 3/2.
Yeah. Then I plug it into the right.
And so then you plugged it in for this thing here. So you get y, I'm going to write this here, y equals 9 minus 4 times 1/2 x plus 3/2. Is that right? So you get y equals 9, and then that's going to be minus 2x, is that right?
Yeah. And then
Minus
minus 6.
6. So that's going to be negative 2x plus 3.
Yeah.
And then you graph the thing. Now this time, they kind of ratchet up the degree of difficulty a little bit in that they give you a time limitation too, don't they? So negative 2x plus 3 is going to look something like this. You have plus 3 up here, then you have negative 2x, and so the thing is going to go something like this, right? But then we have to concern ourselves, don't we, with what 3 is. And if we plug in 3 for t, what are we going to get? We get 3/2 plus 3/2, 3, right? So 3 will be about right here. And then if we plug in 5, what do we get? Well, we get 5/2 plus 3/2, 4, right? Did you say 4? 4. So what we're going to do is we're going to get just this little piece right here. Okay? So that's going to be as far as we have time to go today. We'll pick up on this tomorrow. Thank you for participating, everybody, today.